Thanks, Scott, and good day, everyone. Excited to be here to share. Let me give you a brief overview of what we're trying to do. We are in the realm of helping operationalizing DTN networks. Basically, moving into a place where I think, Roy, you alluded to it, how we can help from the operational perspective on that. So today, as Scott commented, we're going to be focusing around building DTN capabilities for LunaNet service providers. And with that, I'm going to do a 30-second introduction on LunaNet, because I think many of you are very well aware of what LunaNet is. And then I'm going to go into specific topics about building those capabilities for LNSPs, LunaNet service providers. LunaNet is the architectural framework to deliver data communications and positioning, navigation, and timing for lunar or cislunar communications, including lunar surface and the communication between moon assets, people, and Earth. It started from NASA, now ESA, and now JAXA joined, including academia, research organizations, and the private sector as well. So right now, LunaNet is the reference for data communications. And within LunaNet, we have the concept of LunaNet service providers. And this is analogous to the internet service providers, ISPs, on Earth. The goal of LunaNet service providers, as the name indicates, is to provide communications and PNT services to the LunaNet users. In this talk, we're going to be focusing around communications. I'm going to lead PNT to the PNT experts. Basically, the first thing that you do when you're trying to specify interoperability, and that's part of the LunaNet interoperability specification, I think we're in draft version 5 right now, is to define the different interfaces. And you have this picture. This is coming from the draft specification itself. But basically, just to highlight is the fact that, as you indicated, there are users and there is the network and the service provider or service providers managing the network and providing network services, delivering service level agreements, and ensuring that the data can transfer between the different assets. And as you may imagine, there are going to be surface elements, orbiting elements, and elements in the ground to enable that happen. And the next thing that is super important is to highlight the protocol stack. The data protocol stack relies on the Internet Protocol, IP, and relies on the bundle protocol to provide the data communication as services. And below that, the different interfaces, link layer and physical interfaces, depending on whether you're in surface, orbiting, or ground. So let me double click on one of the key elements, delivering security. Security is important because you need to protect the end user's data, but also you need to protect the network. So let's see what the state of the art in terms of what the specifications are saying. On one hand, we have the LunaNet specifications that is very high level right now. It's saying, you need to protect data integrity, guarantee availability of the network, and being able to prevent unauthorized access, corruption, interception, data loss, all the typical, all the typical stuff. And one thing that is very important is that users are expected to use data encryption. What they are saying is, it has to be end-to-end encrypted at the application level for that matter. And in terms of networking, it refers to the typical networking security protocols, IPsec for IP and BPsec for the bundle protocol. And for those who doesn't know much about BPsec, BPsec provides integrity and confidentiality services to different extension blocks that provides integrity and confidentiality. And in addition to that, there is the concept of the security context, which is a very nice, elegant way to ensure that configurations, algorithms, etc., are transferable. That's basically to guarantee that when you say I'm applying X security, the other end knows basically what it means to be able to basically decrypt or validate integrity. And that's it. So there are quite a few security challenges that are open. This is part of our research that is ongoing on our side. We did a preliminary publication of these last year. which is we try to compare the DTN networks based on the bundled protocol with standard internet security and the vulnerabilities we know that already exist. Because at the end of the day, this is a data networking architecture. And there are a few things happening out there. The first one is the DTNs based on the bundled protocol have an attack surface that are susceptible to lateral movement and to topology attacks. And that comes from the fact that our addressing relies on public addresses. The bundled protocol node IDs, these are public identifiers. They can be spoofed for that matter. The service IDs behave pretty much like the TCP or UDP ports. They can be scanned, and then you can guess, and you can try to mess with the applications in the same way that it happens on the internet today. The current DPSec setup is complex because it means that you trust your peers and you trust each other, which in a user-to-network scenario, that's not the case. You think about the internet, you never trust the user. It doesn't matter whatever the user is telling you, you don't trust the user. So there is something to do there on that realm because of that tight coordination won't exist in a user-to-network scenario. Then one thing that we all know, implementation of management in general is still not an operational capability. So there is work to be done there. And just as part of the way or the scenario where DTN works makes it impossible to do, pretty much impossible to do content inspection in the way it is done on the internet, where you centralize all the content in the cloud. You can apply all the AI, put all the cloud resources to analyze the content when the content is in Mars, in a rover, or in the Lunar Gateway. You may not have all these capabilities because you cannot send the data back to the most powerful data center. So these are some security considerations, part of the open state of the art. And what we have been doing is trying to address some of those, not only from the security perspective, but from the whole operationalization of the network. And that's what we call we have a list of DTN capabilities or network capabilities that have to be embedded in the network. And we're going to do that through an example scenario. Some of you have seen this before. This is a prototypical scenario in which we have 3 service providers. Service provider 1 in green, LNSP, consists on DTN nodes that are in lander, in ground, and then a relay node. So this is lander, relay, gateway node. It has some user interfaces or user to LNSP interfaces to connect to payload nodes, whether it is on the lunar surface or in ground. This LNSP uses the services of LNSP3, basically relay services of LNSP3. And then LNSP2, which is here, is an LTV. You don't see it, but it's an LTV that it's using the services of LNSP1. And of course, the LTV has its own payloads, which basically also communicates to ground. So let's explore some of the key capabilities that have to be enabled. The first one is network management. Then we're going to look at how we can deliver a secure user to LNSP interface. Then how we manage the inter-LNSP interfaces, because at the end of the day, LNSP1 is interacting with LNSP3, LNSP2 is interacting with LNSP1. How can we enable secure interfaces there? Topic that is super important, securing user applications. And then last but not least, how we enable operations and bring in more and more automation capabilities. So network management, as many of you know it, network management is essential to operationalizing networks and applications. In the prototypical example we were looking here, if you count the number of nodes, there are quite a few nodes. And this is just having 2 payload nodes here, 1 payload node here. So this network is going to grow to the tens of nodes pretty quickly. And at that number, then you need to start looking at, and with 3 LNSPs, you need to start looking at how you can automate some of the basic management. And that includes network overlay configuration, node configuration, contact line management, your security policies as a service provider, your forwarding policies, and even quality of service. Because it's not the same if you are transmitting video or you're sending files, the criticality, timing requirements, et cetera, et cetera. This is in this example, and this is using the STINT DTN manager. You can configure a network overlay where you define the nodes, you define the configuration attributes of the nodes, starting with the most basic ones like node ID, like convergence layers. Who is the administrator? Because you are in an overlay, they're going to have nodes that you manage, because these are your nodes as a service provider. And there are other nodes that are in the network that you don't manage, but are managed by the other LNSPs, where they are part of the network overlay. So how do you have enough visibility without controlling those nodes? So that's part of the multi-administration overlays, where you have three administrators collaborating in one overlay to deliver end-user service. And then behind some of the nodes, you're going to have other nodes that are, for example, in lunar surface connected to the lander or in ground. And the same way, these nodes might be managed by other customers of the network. Could be science users, could be other users like, your LTV network, etc. So if you start looking at this, and this is, showing you the graphical UI, when the number of nodes and the number of configuration elements start to grow, then the best way to bring automation is using APIs. Especially if you are looking at mission operations, cross-support operations, then APIs also become essential. And I know this might become obvious, but it's very important to start with elements or areas where we know APIs might be required because of the level of automation required. One example is contact plan management, and we're going to talk about that in a couple of minutes. Second topic, securing the user to LNSP interface. Basically, our proposal is to define the concept of a gateway node. That's something that the ISS has been, this term has been used for many, many years now. Gateway nodes help to, on one hand, simplify the configuration, but the most important part is that it helps to define an edge when you can enforce the service provider. So for that, we are proposing, and we are using within the STINT DTN platform, bundle encapsulation, because it is the best way to preserve the integrity of the originating bundle end-to-end, and at the same time, apply your own security policies, your own forwarding policies, your own POS policies on top of it. So for example, you can perform topology hiding because you can define, using a gateway, you can define default routes in which you say from node A to node B, use node 1. And that's all you have to know. The same way as your home internet router works. There is a gateway address. Everything that is not local is sent to the gateway. It's going to get there somehow. And that's the magic of networking, right? The second part of it is that you can define your own LNSP or service provider context, like your own security context, which is only within the network. And then end users can have other contexts as well. That doesn't mean that the end user can go unencrypted. That only means that there would be another security context established end-to-end. So this is a more elaborated example where you see some configuration elements, and this is what I call a marketing summary, in the sense that it's a very simplified configuration just to show some examples. The first one is you can enforce the service provider policies at the edge. That might be security, might be forwarding, might be QoS. And it's basically how the gateway node considers or what to do with the traffic. What security context to encrypt it, what forwarding or how it's going to be forwarded, and what quality of service is going to apply. Topology hiding. node 20, node 11 will reach node 21 to node 1. Node 11 doesn't have to know about node 2, node 3, or whatever other node has been there. So that's critical to make sure making sure that as a service provider you don't expose more information than what you have to. And then the interesting thing, the benefit of this is that these nodes can still have their own VPSec policy, which is end-to-end. So you are basically encrypting end-to-end, and in addition to that, you're encrypting inside the network with your own policy. Next topic, managing inter-NSP interfaces. Gets a little bit trickier because it depends exactly what type of interface or what is the usage. If you are doing tunneling, for example, you could use Vibe, becomes transparent. If you are using a specific asset, then you need to have a trusted interface, and that's more, similar to, for example, in the internet world, whether you have to be part of the BGP routing between service providers, or you just are a user of another network. So you have two options. The most important thing here, and this is something that has been discussed for a long time within CCSDS, is that there has to be a registry the same way as with BGP. There has to be a registry within the service providers to exchange the critical interface configuration data. That's how you connect to each other. That registry doesn't have to be public, especially at the beginning. But if we at Spartan are communicating with another company in a service provider interface, they need to know our configuration elements or attributes as well. And there has to be a specific security policies for that interface. So it adds a quite good amount of management overhead because, as you may imagine, you may have a different security policy for each connection or for each service provider, so you can isolate a little bit or minimize the risk for that matter. So let's go to end user application security. If you look at the bundle protocol specification, currently there is no control between service IDs and application. You open a service ID, there is an application using it, that's it. Is this application file, video, a human, a machine, what visibility they have? Don't know, don't care at this moment. And that's a huge security risk, because the first thing for those who of you that has worked with internet security, when you connect something to your network, there is always somebody who is scanning your port, your IP address. That's automatic. And at some point of time, this is going to happen here as well. So they have to be a part of the zero trust construct is how you control security at the application level. So one of the things that is important is to ensure there is control on the application to service ID map, which means if I open a specific service ID for a specific application, how do we guarantee that only that application can use that service ID? And that talks about implementation coupling for vulnerable. I said I was going to put an example of operationalization and bringing automation. This is contact plan management. One of the things that change very frequently in the networks, because contacts, as you all know, there is a contact plan, maybe 1 month, 2 months long. However, decisions are being made by the day. Contact plans may change by the day, by the week. And multiply this by 10 nodes, 13 nodes, it becomes very complex to manage, especially if you need to pass papers or emails or CSV5 around. So this is an area where APIs would dramatically help. And we and the Patent DTN Manager, we implemented a version to do a contact plan management, in which whether you use a graphical user interface or whether you use an API, you can dynamically add, remove, change contacts, and that's propagated. So this is a web API, gets to the manager, and from there, through DTN, it's distributed to the different nodes to basically act on contact plan management changes. And I said before that this contact plan is a good example because it's so dynamic. But as the network continues evolving and growing and more actors are inside the networks, then this would expand to other functions as well. Last but not least, there were a few things I didn't talk about, like monitoring, troubleshooting, and you might these are standard things on the network, how you can bring, in addition to the autonomy that the management agent or the node agent would have, how you bring data down to the ground automatically through the DTN, so you can analyze that data and based on that build better algorithms, better automation, better autonomy. That's something we also built on the Spatium DTN platform, but I want to focus here on a few open items related to security and management of the network. The first one is node ID allocation. As you know, at least till now, we have a flat pool of node IDs. There is no way to right now to guarantee the validation, whether it is spoofed or not. Simply, it's not there. There's no assertion of the node ID beyond what you can do with your own information. There is a draft that basically goes one step into node ID allocation. At least you can know which entity created or owns that node ID. So this is a precursor to do other form of validation on the node IDs. Another area for further research, as I said, is content inspection. There is still no good answer to that. Key distribution, another one, has been around for a while. And then in a more operational aspect is the inter-LNSP administration. Something that, again, is being discussed in CCSDS, but good to put some action to it to make the first steps into how this information could be distributed across different elements. So we're going to be testing good parts of what I showed today in the upcoming technology demonstration. This is going to happen in the second half of this year, actually pretty soon. And basically, our goal, we're going to be setting up a network overlay where there is a payload node and a gateway node in the ISF, and then a gateway node and a payload node in ground. We're going to be setting up a network overlay from scratch, basically bringing it up automatically using the management, the DTN manager, doing node configuration, contact plan management. We're going to be doing transfer of telemetry and data commanding. The network would support BIBE, support the bundle integrity block, bundle confidentiality block as well, basic monitoring. So basically all the key tenets of an operational DTN network, and this is going to be a good learning for the upcoming LunaNet deployments. With that, I want to say thank you for listening. Just a quick reminder of some of the key capabilities: network management, focusing on the securing the user to LNSP interface, activating the inter-LNSP interface. Don't forget about, we are most time talking about DTN and the network, but thinking about how the user application has to be secure and how we enable operations at service. With that, thank you very much.
We're just about to break for lunch. We've probably got time for one or two quick questions.
I really like the airport, by the way, on I have a question about just like, so you're basically isolating the end users from the rest of the network. So I'm just wondering, like, how in distribution, what happens if each user wants to become part of basically the infrastructure? envision like how you're gonna do that something?
Yeah, so if you become part of the infrastructure, that means that you are a service provider. So you are either a user or a service provider. So if you are a user, then you would communicate with other users. So basically the role of the network is to wire, tunnel the different users of that overlay together. And not only the user, but the specific application. The end goal is that you can do that per application level, and that has to do more with security than anything else. Then if that is another service provider, as I said before, it depends whether the service provider is looking just for tunneling data between two of their elements, or they are an integral part of the infrastructure. If they are an integral part of the infrastructure, they basically have to be part of the basic overlay, although they may use different security contexts for that matter.
And then probably the IPN numbers, or you'll have to take those.
No, not necessarily. At least for right now, being IPNs being a flat structure right now, you don't need to have any hierarchy on the IPNs at all.
I was wondering if in the management plane, does it follow the separation between the security concepts of management and data plane? Do they follow separation?
That's a great question. Yes. So as part of the network design, you need to have your own security context for. It's a good practice to have your own security context for the management plane and your own security context for the data plane. The challenge is right now for those who are dealing with keys is that you are multiplying the number of keys, and you need that is stressed even more the fact that you have to do some sort of key management, which is still open in the state of the art.
How do you see the relationship between, let's say, monitoring of the undefined physical links with the management of the network? I mean, you described a lot of basically on DTN layer, but a lot of these things are based on physical links. Yeah,
that's a great question. There is a network of expression part that needs to happen, but I don't think it's different it's not different than what happens today on the professional income, which is on one hand you need to focus that each layer works appropriately, and then there are some interdependencies between certain layers. Like for example, there is a huge interdependence in the state link with LTP and the physical layer, and there has to be network expression there. Yeah.
With that, I propose we break the lunch. The next event, Alberto.